thing I'm going to talk to you guys about is pruning strategies. So this is not new, so forgive me, you guys have seen this. The MSU fruit team's probably seen this like way too many times, but I think we have 3 years of data now that I wanted to share with you. So we are trying to come up with these pruning strategies to reduce SWD populations. And this really came as, you know, as you guys were telling me, I can't spray anymore. This is ridiculous. I can't continue to spray every, 5-7 days. Is there more of a holistic approach we can take to try to reduce SWD in our orchard systems? So we really want to come up with these pruning strategies to make our whole orchard system less suitable to SWD. So we know we're still growing our trees on standard rootstocks, and we know that these large trees have large canopies. So in other cropping systems, they've shown that the SWD flies will move out of that cropping system, particularly in blueberries, and they'll move to an area that is, much more suitable in the middle of the day. So when it's hot and the relative humidity decreases, those flies will move out. I think in our system, they don't have to move out. I think that the nice canopy is super conducive for these females to just continue to stay in that canopy and to lay eggs in the fruit. So I think that relative humidity and temperature that are within the canopy, I feel like that is, they're not going to waste their resources to move outside our cropping system. That's only our hypothesis. So you guys have seen this slide a million times as well, but this is a strategy that we've come up with based on basically what Myron Anderson did on his farm. So kind of a typical tart cherry grower, he would come in every other year and take out 6 to 8 big limbs. And we also did this in collaboration with the blueberry folks. So Rufus Isaacs, we replicated this in blueberries as well, and our data are very similar, which are nice. So basically we took a tart cherry tree, these are 15-year-old, and then by the time we're done here, they're 17-year-old Montmorency trees across the street, where we didn't take out any limbs at all, so we didn't do any pruning, so you can see pretty hairy trees. And then last pruning, we removed 6 limbs, and then we considered 25% more pruning, we removed 10 limbs. So you can see that this canopy is obviously much more open than either one of those. So the treatments were applied to a contiguous 150 acres, and I'll show you a map because I got that question the other day. So we kind of blocked off areas of an orchard, and then we sampled within the middle of that section. So it wasn't like a row of this or a row of that where you could have SWD that would move between rows. So we did it in 15. We started, a couple of years ago with this. They were 15 years old, and then we had temperature and relative humidity data loggers, and we put those out from June through August. We had adult traps, and then we collected fruit weekly just to see what that infestation does as you approach harvest. And then we collected a lot of fruit at harvest. And then the data I'm not going to show you today is the yield data, because I know growers are concerned. If you prune hard every year, you're obviously going to reduce your yields. So what does that look like to balance your crop load and SWD management through pruning? So those data, we have those for 3 years, and so I'm hoping to get those analyzed and have those ready by Expo. So here's, this is what the map looks like here, and so I just point this out to see that you can see there's about 150 trees in this 25% more pruning, and we take our samples from the middle of that. So you can see that you're hopefully getting that effect of an orchard or that treatment on a larger area than just a single row where flies could obviously move between rows very easily. The other thing is these systems research are hard to conduct because we don't have enough trees here to do that. So we've this map used to be nice thirds, but as the years gone on, it's gotten a little more broken up. So I'm just going to jump right into results. And so you've seen these data before, but these are pruning treatments from 2017. This is the average number of larvae in a half gallon of fruit. In 2017, you can see 25% more and less pruning. We had less than 20% average larvae in a half gallon of fruit. And trees that were not pruned, you can see were upwards of 75 larvae. 2018, the data were a little bit different. And so again, average number of larvae, this is 25% more pruning. So 10 limb removal, 25% less pruning, around 6, and then no pruning at all. We really didn't see any differences in the 6 limb removal or the no pruning. The only effect that we really saw with pruning is when you really went in there and took out 10 limbs. And then in 2019, again, same graph, same thing. We see that again, the average number of larvae is just over 5 and 25% more pruned, 25% less is just under 10, and again, over 35 larvae in the no pruning treatment. So those data are pretty exciting. I mean, I think that's kind of a slam dunk. I think we can stop doing this. Myron, you can stop pruning this way every year. So then we went in and we looked at our temperature data loggers. So these are the hours above 30 degrees C. So this is kind of where SWD becomes less active or inactive. Just it gets too hot. They're not really interested in moving around. So the number of hours above 30 degrees C or 86 degrees Fahrenheit. And then these numbers at the top are the number of SWD larvae. So you can see 2017, 18, and 19 are all dramatically or pretty different in terms of their temperature. So kind of I would consider 2017 a more kind of normal year. So you could see if you have lots of about 130 days above, 130 hours above 86, we have 95 larvae, which was not statistically different than 56 larvae. But you can see once those temperatures are much cooler, you can see you're getting around 450 larvae at no pruning treatment. So it looks like temperature is obviously playing some kind of role. 2018, remember, was hot and dry. And so again, we really only see the value of taking out more limbs or 10 limbs because you only have 19 larvae. And then you have above about 170 hours above 30 degrees C. But at about 130 hours above 30 degrees C, there's no statistical difference between less pruning and no pruning at all. And then you go to 2018 or 2019, which we know was very cool and wet. You can see obviously they're very different. So the hours above 30 degrees is far lower, but you can see that you have less larvae in the more and less pruned compared to your no pruning at all. And it looks like that at 40 hours, you have 222, but if you can get up to 50 or 60 hours, that temperature really makes a difference. So we also did this work with relative humidity, or we have these data with the data loggers with the relative humidity. So these are the number of hours below 50% relative humidity. So the higher bars, the more hours below 50%, so the less humid. And so again, we see those very similar trends. When you see that humidity increases, you can see that we have higher larvae in 2017. 2018, that was hot and dry. There's really not that much difference in relative humidity, but you can see we still have impacts of relative humidity on things that are more pruned, so you're reducing that humidity. And then lastly, you could see in 2018 or 2019 that was very cool and wet, that there are no differences really between more pruned and less pruned, and you really start to see when that humidity increases, we have 222 larvae. The other thing that we were really interested in is light intensity. So we looked at temperature, humidity, but I was wondering if there was something with light into the canopy. So we bought this fancy machine this year, and it's a light meter, a light quantum sensor, which was really, we were just like the fancy lightsaber. But it basically, we did 10 replications in each pruning treatment, and we took these, we collected these data north and south, east and west, and we took 4 samples in 2019. So initially, these are light, so this is micromoles per meter squared, and so these light units are on here, and then here's our pruning treatments again on the x-axis. And I was initially, when we started to crank through or put the data together, I thought, oh, this is exciting, because you can see we have way more light in the prune treatment than we do the 10 limb removal than we do in the 6 limb removal. And then, of course, as in science, you realize that the no pruning treatment we hoped was going to be somewhere down here wasn't. So we went back and tried to say, did we do something incorrectly? And when we went back and looked at the trees that we selected in the no pruning treatments, they just had inherently smaller canopies because they were on a sandy knob. So we'll repeat this in 2020, but it was a little disappointing to see that our no pruning wasn't exactly like we liked. The other thing that we've been interested in trying to understand is in-orchard fruit temperature. So this was something that John Wise turned us on to. So yeah, the canopy temperature and humidity may have an effect, but those individual fruits, do they have a temperature that maybe the females don't like, or they don't like to lay, or if they lay into it, the larvae just don't survive? So we measured the fruit surface temperature. So we basically had this, you know, you could do your steak or you could do your cherries. So this infrared thermometer, and we did this 11 times. And we had this 5 fruit per tree and 3 trees per treatment. And so when you look at these data, this is the average degrees Celsius above or below the ambient temperature. So we would take the ambient temperature and then we would look at if that was above or below kind of the regular air temperature. And what was exciting to see is that all treatments, whether it was more highly pruned or 25% more pruned, less pruned, or no pruned, all the fruit on the outside of the canopy had a higher temperature than fruit on the inside of the canopy. Yeah, that makes sense. So then what we tried to do is we tried to do some AgBioassays in the field. So we had this in-orchard AgBioassay where you had these paint strainer bags and we would place them around 5 fruits in the canopy. So we placed them around the 5 inside and 5 outside fruits, and then we replicated it accordingly. And then we released male and female flies from our lab colony into the bags because we were interested to see, yeah, the temperatures are different from inside to outside, but does that really affect infestation? And so we found that we put the number of larvae, basically we put them in, we left them for 48 hours, and then the number of larvae found after 7 days. We only did 1 replicate because the things kept dying. So we put these flies out in the bag, and I think they're really susceptible to desiccation. So we had these high plans to get out there at 3 in the morning or 5 in the morning where relative humidity might keep them alive longer, and we just ran out of time. So we'll repeat this again, but I think our preliminary data are exciting. So this is the average number of SWD larvae in more, less, and no pruned, and you can see that we have higher numbers of larvae in the fruit that are cooler. So the fruit on the inside of the tree had higher numbers of larvae than the fruit on the outside of the tree. So not that this is a slam dunk, it needs to be repeated, but there may be something to fruit temperature itself. Then we did a mark and recapture study. Actually, we did 2. The first one, I'm not going to show you the data because it didn't work. So the idea was to release these flies in the different pruning treatments. And then we would put red sticky traps outside in a transect to see if they would stay in the 25% more pruned, less pruned, or no pruned. So our data, I think, are pretty good. That really shows that we have lower infestation with the different pruning treatments, but behaviorally, do the flies actually move is what we were interested in. So will they seek out something that has a better canopy, or will they move out of somewhere that has a lower canopy to something, a more open canopy to something that's more dense? So we were just wondering behaviorally, does it affect the flies? So the infestation, we got that, but we were wondering about the flies. So this was based on some work from Danielle Kirkpatrick, who worked with Larry Goot. So we had a ton of lab-reared SWD. We put fluorescent dye in those, and then we released them into 2 blocks. I'm not going to show you the information from the pruning, different pruning treatments, because we recovered so few flies that it really doesn't look like there's a difference. However, we decided to do this in George's cherry leaf spot efficacy block. So Dr. Sundin has an efficacy block up here every year, and every year he's got treatments that look like this. And so treatments that obviously aren't working for leaf spot, so the trees are defoliated or mostly defoliated. So what we did is we released almost 4,000 flies in this block at the station, and we had half of the block that we treated kind of normally that wasn't part of the efficacy trial. And then George's treatments down here, you could see, had very open canopies late in the season. So this was mid-September. So we released 4,000 flies, and then these numbers indicate the trap location and the number of flies that were recaptured by baited sticky traps. And I was really pleased with these data. So the full canopy trees, we recovered 17 SWD in these canopies, and then in the defoliated trees, we only recaptured 6. And I know those numbers don't seem impressive, but you're talking mini flies with mini fluorescent dye, and Karen sitting in a dark bathroom trying to see if she could see them on a red sticky trap. So this was a lot of work for these data. So the average number captured, you can see full canopy does have more than the defoliated trees. We'll repeat this in 2020, but I felt like it was at least promising. So to conclude, I think our pruning decreases SWD infestations. And so not that I want to add to people's workload, but I think you can get some benefit by really pruning those trees hard to really reduce SWD. I think more intense pruning, 10 limbs, is needed in a hot and dry year, but I think in most normal years, that 6 to 10 limb removal to open up that canopy is likely adequate. The pruned trees had higher temperatures and lower relative humidity, which resulted in lower SWD infestation in 3 seasons. So like I said, I think we can put this to rest. And then our preliminary light data show that we do have higher levels of sunlight in things that are better pruned. But like I said, we need to repeat this light work in the future. And then again, that mark and recapture study provided evidence that aligns with that SWD prefer denser canopies. So that's all well and good, but here's where I want to go, or I hope we can go with this, is our goal is to develop pruning recommendations that quantify. So how much light do you need to reduce SWD? How low does the temperature need, or how high does the temperature need to be? How low does the relative humidity? And all of those ranges and interactions, what kind of thing can I provide you guys as a quantitative way to measure how your pruning looks to reduce SWD? So I got a little skewered the other day at Great Lakes Fruit Workers. Terrence Robinson's like, well, Nikki, what's 10 limbs? What's 6 limbs? You know, and it's like, yeah, I get it. But I think that's where we're going, is trying to figure out quantifiable ways to measure this so you guys will know. And down the line, I would love if you guys had some kind of app on your phone that you could put up in a canopy that shows you guys, you know, what that magic number of light intensity, temperature, and relative humidity, that you knew you did a good pruning job to reduce SWD. So I don't know if that's that far off. I feel like we're closer than we have been, and so I was pretty excited for these data. So again, I'd like to thank the ROAR program, MBA Block Grant, Cherry Committee, Michigan State Horse Society, Project Green, and of course our staff here at the Northwest Station.